Hi everyone, my name is Gema Hernan and today I will present my work about comparing anchoring methods for seagrass restoration. Seagrasses are critical components of coastal systems and provide crucial ecosystem services such as habitat and coastal protection. However, these coastal ecosystems are under increasing threat from anthropogenic activities. In response to this crisis, enhancing recovery through active restoration, such as planting, is one of the strategies used in seagrasses, especially considering that recovery through natural succession is a slow process. The success of active restoration is low in seagrass system, less than 40%, and costs remain high due to the difficulty of working in the marine environment. The study that I present today was carried out in two shallow embayments in Mallorca, Porto Colom in the south and Formentor in the north. Here, Posidonia Oceanica has regressed in both sites due to anchoring activities, and a delimited area in which anchoring is now forbidden has been established. Also, there was evidence of prior existence of Posidonia indicated by the presence of dead mate that has been identified as the most optimal substrate for planting. Detached fragments of Posidonia were collected in situ via snorkeling or scuba, and they all had an active growing meristem and exhibited good health. We tested four anchoring techniques: big steel staples coated in wax to which fragments were tied with a thin rope, small garden staples, bamboo sticks, and a handmade calcite structure, but these were only used in Porto Colom. There were 5 replicate plots per treatment, and each plot contained 16 fragments. Planting was performed between October and November of 2022, and plots were monitored 6 times during these 2 years. We also assessed a suite of non-ecological indicators such as weight, buoyancy, devices lost after 2 years, cost, supply, or carbon footprint, and these indicators were scored from 0 to 2, being 0 the less feasible and 2 the most feasible. A total feasibility score was calculated as the sum of these individual scores. All along the experiment, we measure other ecological variables, and in the figures we will see that brown corresponds to bamboo sticks, green to big staples, blue to small staples, and yellow to calcite pegs. Establishments as sex, which is a proportion of fragments relative to planting, vary through time, being significantly lower at later monitoring times, but usually it's the first 2 years when biggest drop in survivals occur. But the overall success after 2 years was 80%, which is reasonably high. Small staples provided the highest establishment success, 90% at both sites. We measured the percentage of fragments gaining or losing shoots after 2 years, and we found that over 50% of fragments were losing shoots, 34% produced new shoots, and also that big staples had more fragments producing new shoots, but this method required longer fragments at the beginning that were more difficult to find, so only 30% of the detached fragments found had these requirements. Fragment dynamics were measured as the change in number of shoots per fragment relative to planting time. They differ among anchoring methods between sites. In Formentor, small staples show a tendency to decline in shoots per fragment after planting, while the other have an overall positive change. However, in Porto Colom were bamboo sticks that had a steady decline over time, while the other methods had an overall increase. Regarding non-ecological indicators, small staples are the most feasible due to its negative buoyancy, low cost, fast and easy supply, and low percentage of material lost after 2 years, only 3%. Bamboo sticks had a good score thanks to the reduced weight, low cost, fast and easy supply, low carbon footprint. Finally, high materials lost, over 16%, high cost, over $3 per unit, and high carbon footprint are the indicators that more negatively impacted the feasibility score of calcite pegs and big staples. The inclusion of complementary non-ecological indicators can be crucial in decision making and playing a key role in determining the overall feasibility of restoration actions. Incorporating these considerations into a decision-making matrix ensures the restoration methodologies are both effective and sustainable in the long term. Thank you so much.